All right, everyone, get your seats. We're gonna have Karl start us off. Yay, science. Wow.
I have a huge, oh no, I just yelled.
All right.
Okay, let's thanks for hanging around and listening on the second day. My name is Karlstrom. I'm a just retired professor at the University of New Mexico. My wife and colleague Laura Crossey and I co-author lots of things, and but I'm going to do all the talking this time. I want to leave this question at the bottom. How do you date a river system? Just think about that for a minute. But in the meantime, I'm going to put in a plug for the geosciences and the importance of interpretation of the geosciences to the public. Grand Canyon is one of the best places in the world with stories that range back almost 2 billion years. And boatmen have a chance, I think, to, you understand the stories encoded by the rocks, you can impart a little bit of that to your passengers. It enhances their trip, and it gives us all a perspective about how our lives, our short lives, from a geologic point of view, interact with these different time scales. So the long debated questions about the age of the Grand Canyon and the age of the Colorado River are entwined questions, and yet somewhat different. I think we made major progress in 2014 in the Nature paper about how Grand Canyon itself has different segments, which have different histories and different carving ages. And now we're going to focus on the river itself. That's the age of Colorado River. And we're going to approach this using a couple of tools. One is we're going to try and date sand grains. We're going to get ages on the sand grains that's being carried by the river. And also, we're going to ask the fish, the genetics of different fish species about when their ancestors first came through Grand Canyon to the Gulf of California. I'm not a fish person, but we have a team at the University of New Mexico, Tom Turner and Megan Osborne, that have helped with that aspect. There's 10 or 12 authors on that page that's in the handout. So here's the go with the flow idea. Sand grains are going with the flow, and so are the fish. And we're going to talk about the Colorado pike minnow, bluehead sucker, bony tail, chub, and what their genetics tell us. We're going to ask the DNA of these fish when they first joined the Colorado River system. We dated over 10,000 grains. And this whole thing about time is informed by new and better techniques to date rocks at all time scales, geochronology. And so some ongoing things you'll hear more about. We've got a new 5-year project on the QR group, one of the best places on Earth to study transition from prokaryotic to eukaryotic life on Earth. Who saw the article about the penis worm and the new soft-bodied critters in the Cambrian? So, like the Burgess sail, we now have found soft-bodied organisms in the Cambrian. And then I'm trying to finish up 40 years of work in the basement. So we'll have new maps, river corridor maps at a pretty detailed scale, 1 to 24,000. We have now submitted the middle gorge and the lower gorge, upper gorge next. We got to get them peer reviewed before they circulate. So that's why you haven't seen them yet. Okay, so here's collecting a bunch of sand. And of course, it's all a lot of quartz. We want to get rid of that quartz, separate out the feldspars, upper right. And the feldspars themselves, some are good, some are better. But the clear one, the sanidine, is a volcanic potassium feldspar, comes out of these super volcano eruptions, and it's really a great mineral to precisely date, single grain. So we're going to date about 10,000 of those after we do all this separation to get the separates and then pick out the grains. And then we produce these kind of graphs. And these red things are like histogram, so more higher peak in this 60 to 40 million year range, or 20 to 40, some old grains in there. We use these in a couple of ways. One is if we find the youngest grain in that bunch of sand, the sand has to have been deposited after that grain, right? The grain existed before it was transported and deposited. It's called a maximum deposition limit. And we use that to date terraces in carbon. But we're not doing that so much here. Here we're looking for tracers. If we can find a grain where we know it came from and trace it down through a river system, we can determine through different age sediments, we can determine the history of transport of those sand grains. So on the right here, this is just to get you so you can see these, how many grains we dated from a given sample. And I'm going to show some data up here, but I don't, the data is less important than the concept, which I think is we finally have made a major step in understanding how the Colorado River became integrated from north to south between about 8 million years and 4.8, which is a very firm number when the first Colorado River fish and sand grains arrived in the Gulf. So we're going to focus, we live in this erosional landscape, which makes it so beautiful, but we're going to focus on a few places where there's sediments, basins that we can date to figure out if there are sequences of arrival of grains and fish that we can pull together into a history of integration. And the story is up there in the north, the Chalice volcanic field, the Idaho Batholith. That's the only place that I can find anywhere that has a large number of 40 to 60 to 40 million year sanidine grains. So that's my tracer grain. And we want to see, are they in this Browns Park formation or in this Chattahoochee formation? When did they get into, we call them the loco basins, lower Colorado basins, and into the Gulf? And they're different than these southern ignimbrite supervolcanoes like San Juan volcanic field, Marysville, Buggy-on-Dale. Those are 20 to 40. So we think we have a tracer that we can use to understand the integration of the river system. So our hypothesis is that we have like a 3 million year north to south, downstream, downward integrated river system that had its origins up around the Snake River Plain when the Yellowstone hotspot went across. The Rocky Mountains were being uplifted by mantle forces. And so the whole plateau was tipped to the south to generate this river system. So that's the key story. And now we're going to look at a little data. Your eyes can glaze over. You can send me emails about any of this. The paper itself is going to come out in Nature soon. And the paper's short and very, very simple. But the backup data is extensive and kind of scary. Do you think I can go back and run that again? Before you do, though, I want you, when I do it again, we still have two big problems. How did we integrate across the Uinta? That's the Uinta Mountains. And so this is the green Colorado coming down. And you notice that this Chattahoochee formation out on the Little Colorado River is going to be a big part of this story. And then the other question, which Karl and others have noted, how did we get water from northern latitudes across the uplift? So there's two things that Karl noted where the rivers are crazy and go across the uplift. We know when they happen now, I think. This one was breached 8 to 7, and this one 6 to 5, but the processes are still suitable for debate. So let's watch that again. So for those of you interested in the Uintas, there's 3 possible pathways. The door up here, the Yampa as a headwater. And then this area here was the oldest part of the Colorado River, which is now preserved as gravels beneath Grand Mesa near Grand Junction. So we're making progress. You gotta think of rivers as segments. When did they come together? Okay, so I wanna focus a little bit on these different basins where we dated all these grains and just take a look at this tracer grain, 40 to 60, which we think the only place it could have come from is up here. So we have a problem already because the Snake Columbia drainage is separate from the Upper Green River. And that's an exciting thing. There's all kinds of work being done up here about how the Snake through Hell's Canyon is really young, like last million years, kind of like parts of Grand Canyon are really young. But so this divide is still a bit of a mystery. Browns Park Formation here, there's the yellow is just the 40 to 60s. We're trying to focus in on these tracer grains. And notice the distribution. We'll look at this cumulative graph here. It's the easiest. This is about the chemistry of the grains. This is about the histogram. But anyway, there's the pattern. In the Betahoche Formation, same pattern of 40 to 60s, but notice the age difference. The Browns Park stuff was accumulating until 8. The Upper Betahoche 7 to 6. Same pattern of tracer grains. And then here are the ones down here in the local basins, same pattern. So we believed our eyes and we said, oh, those are pretty similar patterns. And we think that this might provide a solution for, got to derive them up here because we can't find any other place. All these white dots, by the way, are where we've done detrital, sanidine, and chalcocircon studies in other areas. There's no 40 to 60s, all those white dots. So the 40 to 60s came from up here. And by the way, in Eocene, they came both sides of the older continental divide. The continental divide has shifted to this modern position over here, the black line continental divide. So rivers and landscapes are dynamic as uplift takes place. Okay, so this is the bottom line. You can go to sleep now. These 60 to 40s sanidines were reworked north to south in 3 steps. These are the places where there's preserved sediment. And that tells us about the integration of the Colorado River. Why those places are preserved is interesting. We now have these papers about how these were drips, mantle drips, which pulled down across, up direct where the water was going to accumulate and path of the river. Okay, so the conclusions, and I'll keep going. 60 to 40 sanidine came from the north. They were reworked in the steps, made it to the Gulf at 4.8. So that's an important number. It's very firm, and all the white dots in those 60 degrees. So you believe your eyes, at least I do. And as long as the statistics proves what I already know, I'm happy with the statistics. And here's the statistics. There's all kinds of ways to compare these populations. And the dots there, these colored dots, are the ones of interest, these main 3. And then a comparison to a thing called the Markley Formation, which I won't go into, but that's our best proxy for what the assemblage, the whole summary of all those northern volcanoes look like. And they agree quite well, and they're different than all these other things with those white dots on the map. Okay, so what about the fish? Again, I'm not a fish expert, but the fish genetics are used sometimes, very frequently actually. They apply this molecular clock hypothesis. That is, that the rate of mutations of the species, accumulation of defects or changes in the DNA change, is somewhat regular for a species. So you say, okay, how different is this one from this one? How many differences are there? And then you apply this study of, or this rate, and you get a divergence time between 2 taxa from a common ancestor. And so it turns out that these pike minnow have Atlantic affinity, just like the Green River fish did. They separated from the Snake Columbia drainages, which also have Atlantic affinity, back here at this junction in the tree, which is about 12 million years. And the suckers, the mountain suckers, I'll show them the next one, also about a 12 million year divergence from their last common ancestor up in the Snake River. So are you with me? These are the fish that are swimming around today. Of course, pike minnows only up in fish hatcheries and stuff until we get reintroduced. But their genetics is telling us that Colorado River has been separate from Snake Columbia ancestors for this fish for about 13 million years. That's that divide that we have to get across to get water into the Colorado. These two here actually diverged 7 million years ago, childhood pike minnow. And there's not really a question of what you mean by divergence. The other option is they introgressed. These were naughty fish who got attracted to the other species. And so this 7 million year number reflects the time they came together in the Chattahoochee Basin. But anyway, so these trees are applied. We're not providing new genetic data. We're just saying, wow, that's published stuff. It's more or less in agreement with our downstream integration model. Timing. These are the fish from the Chattahoochee. They get as long as 75 centimeters, almost a meter, and the modern pike minnow up to a couple of meters. The beauty of this study is, since John Spencer's really great work on this in 2002, I think, we've just expanded it with more published data on species and trees and the bluehead sucker divergence from the Snake Columbia about 13, and then this 5.1 divergence between the upper basin and the lower basin mountain suckers is the time the fish went with the flow through the Grand Canyon. So, okay, so here, I'll kind of go a little faster and summarize this model, just so you have the model, and we're glad to dig into detail. This is called a cladogram, which shows the fish divergence nodes. The fish divergence nodes correspond to the river integration steps. So here's the passage to the Yellowstone hotspot between about 12 and 5. That rerouted the Snake and probably caused this divergence between Colorado and Snake River pike minnows and suckers. Browns Park was deposited 23 to 8. And then, so here's the Yellowstone hotspot track. There's a lot of work that this study promotes. Every time you make progress, you ask me questions. But anyway, these 40 to 60s accumulated between 23 and 8 in that basin. We have to get them out of there. This is the major contribution from the new sanity dating, is that the upper Chattahoochee formation is now really well dated. And the fish arrived between 7 and 6. And this is White Cone Butte on the Navajo Reservation. Here's lower Chattahoochee, 16 to 8 million. Here come the fish, and this is Gene Shoemaker's old diagram with fish and mammals and rhinoceroses and beavers and really rich riparian habitat in the Chattahoochee, upper Chattahoochee formation that marks the beginning of the Colorado River. There was no Colorado River leaving the Colorado Plateau before this integration. That's the model. Okay, you get into the Chattahoochee Basin. Now you're in the question of, did it spill over to form Grand Canyon? There's a lot of papers about that. And if it did, at what height? And we're just trying to show you how much data we have for the stratigraphy of the Chattahoochee now, which says that the first 4th to the 6th grades and fish from the north got into this basin before Grand Canyon was carved, 7 to 6. And then how did it get across the Kaibab Uplift? This is kind of an old paper now, but it's always been interesting that in the 6 million year age of the upper Chattahoochee, when that quit being a separate basin, and the 6 million year age of the last Walpi limestone are the same. And this didn't have to have a lake that spilled over the Kaibab Uplift because there were already paleocanyons as per our 2014 paper. But the confluence, here's the gap way in the background. Here comes little Colorado. The thermochronology tells us what the landscape looked like at 6. And has a paleo valley here, anywhere in those upper middle parts. So that's the integration path we favor. We got to get through the Grand Canyon with that 5.1, 6 to 5, that 5.1 divergence into all these local basins. Local basins, Fowles Formation, you may know about. Every single unit. So the blues are Fowles Formation, Colorado River sediments. The yellows are the sediments that predated the Colorado River. All the blues have 40 to 60s, all the yellows don't. So these grains did not see the Gulf 4.6. So that's again sensitive data, and I'm out of time. But thank you very much.
Want to take 2 questions? We have a couple questions out there. Oh, we've got Shannon over there.
Yeah. That area is so deeply eroded. So yeah, we've got to get into those maps a little bit, but okay, the question was, that showed the pathways shown going, coming down the green and what Colorado green meet, coming down and then sneaking across the Defiance uplift, coming into Bittahoche Basin, up Chinle Wash, a major valley where the river's now going the other way. And so is there any evidence for that? And the answer is it's very deeply eroded. And so it's one of these called an underfit canyon. That canyon is bigger than the river, the creek within it now. So it's possible, but there's no physical evidence that it went there. The other thing you might have noticed is I don't have Marble Canyon in the integration path because the thermochronology says it wasn't carved till after 5. So at 6 million years, the integration path didn't include Marble Canyon in this model, but that starting around 5, you can get water through there. So think of the river as segments, with segments coming together, seeking a lower base level as the Rockies are being tilted. Gulf of California is opening, and this water and the fish and the grains are all trying to get downstream.
One more.
So the overall north to south progression you think is related to like some uneven delamination in the mantle, that it was just kind of tugging on the southern part of the plateau a little more, causing everything to flow south.
Yeah, in a general way. In a more specific way, the passage of the Yellowstone hotspot had major uplift at the divide between the Snake River and the Green River drainage. And those volcanoes were blowing their tops off between about 10 and 5.
Do you think that might be the bigger driver of
That's what that ultimately drove it. The Rockies were uplifting at the same time, and that tipped everything that way.
Let's give him a hand.
Who's that? Larry John?
Oh, yeah.
Here we go. All right, sweet. Thanks, Karl. Next, we're going to hear from